The inspiration for this project was a game called Guitar Hero. The premise of this game is the interface of a limited guitar controller with 5 buttons and a paddle. The users were to press the buttons as indicated by knobs on the screen, then pressing the paddle when the knobs reach the bottom. There is also a tilt and whammy bar functionality in the interface to access special rewards in the game. This is dissatisfying if you're trying to learn how to actually play guitar, or if you're already a learned guitarist. However, it does get you motivated to play. A real guitar is much more complicated, and an interface is proposed in this video and in the report. There are 2 aspects to this interface: the audio, to see what notes are being played, as well as a video, which will determine information about where the user's fingers are. Every electric guitar has an analog signal out from their pickups, and pickups for an acoustic guitar are relatively cheap compared to a software package. If we look at the waveform coming from this signal, it may look like something like this. The first spike in frequency amplitude space represents the frequency of the first fundamental. The other spikes are overtones. If we look at a more complicated system, we will propose an algorithm to deduce which maxima are fundamentals and which are overtones. Let us first mark where all the maxima are and take note of the first maximum. This maximum will be the first fundamental. Given any stringed instrument and a fundamental frequency f0, we can predict where the nth overtone is by the equation Fn equals f0 times n plus 1. Now we can exclude all maxima with frequencies of these overtones for a given fundamental. After we have excluded overtones from the first maximum, we move on to the next and repeat the process. We now have knowledge of all the notes being played on the guitar. Now let's move on to video. The video system we will use is a simple webcam attached near the base of the neck of the guitar. This area is not near where the player picks or plays, so we can use this region to record data about the strings without interference from the player. This is also the area of greatest amplitude in the strings. At every instance in time, we have 2 frames which are being compared: the one currently being recorded by the camera and the rest image. Let us look at the rest image. The way our proposed filter works is a simple Gaussian blur followed by a Sobel mask along the y-axis. After this, we take the absolute difference between the filtered rest image and the filtered captured frame. For the 2 frames shown before, we can see that the region where the string was moving is now highlighted. Now we can compute which strings are moving. Let's put it all together. There is one more thing we wish to compute using this data. Given a rest frequency and a current frequency, we can compute which fret it's on by the following equation. We tweak this equation with offsets for each of the different strings. We can creatively compute which frets are being played by going from the lowest to the highest string. Since we know which string is being picked, we can assume that the frequencies on the string are non-decreasing. This may limit some chords, but is sufficient for our purposes. In my presentation, I demonstrate how the frequencies work on the guitar by increasing a frequency starting at 1.0 by 0.1 every tick. At the first octave, the frequency doubles, and triples at the second, and so on. I also show how using bounding boxes in a given area of the mask with thresholding can lead to a rather promising result of the interface. This works rather well for seeing if a string is vibrating, not being picked. We have seen one possible application of this interface, the rhythm video game. With a more complicated input, one could start off with an easy version of a song and progressively get harder until the real song is learned. This would be just as fun as Guitar Hero, except have a steeper learning curve. Another application would be the virtual teaching instructor. This could display chords and passages on the screen and ask the student to play them for it. If the student is making many mistakes, the instructor could tell them what they need to practice as well as what they're doing wrong. This is just like a real instructor, except the virtual instructor can't force the student's hands into positions they're not accustomed to. The last application presented here is the auto-tabber. A tab is a form of sheet music that is expressed in 6 lines, with numbers on each line saying what fret on which string should be picked. Instead of painstakingly making these tabs in Notepad, it would be very beneficial to have something that could see what you're playing and do it for you.